Hello friends, now I would like to give you a lecture about the protein data bank and what is the information they have been stored with them. And so I can just give you the I don't think so there is no such videos which gives you a good detailed explanation about the PDB format. So I would just like to give you an intro about that, so you all can get familiar with what is the information and what each line refers to. So yes, so how do you get the PDB information? Okay, how do we get information about a protein? We can get information about a protein from a protein data bank. You can get information about from the protein data bank or from the PDBE. Okay, so the PDBE is something which is maintained at the EBI, and the protein data bank is the one of the traditional one. Okay, so yes, in the protein data bank, the format of a protein data bank is something like this. Can you see this? I hope you all can see this. Can you see this? Yeah, I hope this is visible. Yes, now this is actually the format of the protein data bank. Okay, so this consists of approximately 80 columns, and where the first 6 columns refers to your record name. For example, it can be a header, it can be a compound, it can be a source, it can be an author, or it can be a seqres, the sequence it can be. Then you have from 11 to 50. Okay, from 11 to 50, that is the string 40 classification, which classifies the molecule. Okay, next you have from 51 to 59, you have your deposition date. This is the date which has been deposited to your protein data bank. Then you have from 63 to 66, you have the code for which it has been deposited, and in the end also you have the identifiers given over here. Can you see this identifier? Yes. Now in the header section, what do you have in your header section? Your header section will consist of your protein, your PDB code which is there, and this is your deposition date. Whereas the header section can also follow with the other sections such as your compound, your source, and an author. What does a compound give you? What is the information about the compound? For example, when we consider the ICM or the ICN, it is a fatty acid. Okay, so it is an interstitial fatty acid binding protein mutant with an arginine 1.06, which is replaced by a glutamine complexed with oleate. So what is this 2 refer to? This 2 refers actually the second line of the compound, whereas over here this refers to the second line of your source. So these were the authors who actually found the structure of this protein, this binding protein fatty acid. Okay, that is the 1-ICN. Okay, so next what we are going to see is this. Can you see? I hope you all can see this. This is actually the PDB format of the it is actually I have actually downloaded the ICN format, and I have actually printed this. So this is general PDB format, where you can actually find the header, the title, the compound, source, the REV data, JRNL, remark. So now we are going to talk in detail about the remark. Okay, so because this remark is one of the most important section over here. So when you consider the remark 1, the remark 1 has actually the cross references to the earlier recent papers, whereas the remark 2 consists of the resolutions, which it may be in Armstrong's or anything like that. So next we also have the remark 3, remark 4, and everything. So what is the information which is actually, now we can see what is the information which is actually stored in your remark 3 and in your remark 4. Okay, sorry ma'am, sorry. So I think the phone has just flipped. So yeah, so in the remark 3 what we have is we have the information about how the structure has been refined, how well the observed data agrees with the model or the R values, and it also gives you an estimate of the quality of the stereochemistry. The stereochemistry is the RMS deviation of the bond angle and the dihedral, and usually an estimate of coordinate errors. Okay, so for example, I can show you the remark remark 3. Can you see this remark 3? This one over here. Is it? I hope this is clear. So you can see the remark 3, right? So as I earlier said you all about in the remark 3, we have the information about the structure as how the structure was refined, and we also have this observed data, how the observed data agrees with the model, which is the R values. Can you see the R value over here? So it gives the R value, the RMS, the bond distance, the RMS, the bond angles. That is your stereochemistry data. Now we also have something called as a remark 4. This remark 4, that's the other important information is in the remark 4 as well as in the remark 5. This remark 4 gives you the difference between the Swiss prot and the PDB sequence. And you also have remarks 6 to 9, which are not actually assigned, and 100 to 99 are used actually for the nucleic acids. And the main important content you have in the remark 200, which gives you the X-ray experimental details, whereas this remark 300 and remark 350 will give you the information about how to generate the biological molecules from the coordinates. And the most important thing is SEQRES. I'll show you this SEQRES also. This is how your SEQRES looks like, and this is your 3-letter code of your amino acid. I think you can see this now. Yes, this is your 3-letter code of your amino acid. It gives you the amino acid sequence, okay, in a 3-letter code. With the, can you see this last line with your unique PDB ID? And this represents the 1, 2, 3, and this represents the number of the lines. It shows the 11 lines over here, and this shows this. Can you see this is your amino acid, for example ALA, this is your alanine, and if you see the HET is nothing but you have also the HET-ATM, that is the heteroatom, which actually corresponds to your water molecule. Okay, so this is the most important information which is actually stored in your PDB. The other important information which we can actually get from the PDB is, can you see this? I hope you all can see this. We can also get the information about the secondary structures. See here, the helix, the sheet, the turn, and you also have this helix, sheet and turn, and which chain does it belong to, the A, B, C, and what is the amino acid. In a 3-letter code it is given. Can you see that? Okay. Yeah, now you also have this CRIST1 data. 1 minute. Yes, you have the CRIST1 data. Can you see this? This tells us the unit dimensions, where this value corresponds to your alpha, this corresponds to your beta, this corresponds to your C value. I'm sorry, this is your A, this is your B, this is your C, this is your alpha, this is your beta, and this is your gamma value. Okay, so the scale, what does this represent? The scale 1, 2 and 3. This presents the transformation from the orthogonal coordinates as contained in the entry of the fractional crystallographic data, the crystallographic coordinates. Okay, next we can also see this atom file. Can you see this atom file, which is actually the most important file which we actually require? In this you can actually get the most important information such as the B factor, your X, Y and Z coordinates, your occupancy. Okay, so when you consider So this is your, I hope this is visible. So this is your x, this is your y, this is your z coordinate, this is your occupancy factor, this is your b factor, and this is your PDB ID code, okay, and this is your amino acid. So for each and every amino acid, and this gives you the atom information. So this is the most important information which we actually require in order to analyze your protein structure, okay. Analyze your protein structure. So now we can see that so I think we have actually come to the conclusion of this small session about the PDB. And the thing is, the PDB gives you the data about the protein structures, and here most of the data is deposited is by the X-ray. 90% of the data deposited in the PDB are by the X-ray, and actually it has a very unique identifier. And once you have downloaded this PDB file, you can load it in a PyMol or any other visualization softwares. So you can find the binding sites of them. You can analyze the binding sites of these proteins with the help of this information we discussed about, the atom file or your the helix turn and everything. With these data you can actually analyze more. Thank you. Hope this video was useful.